Hello everyone, my name is Shambhavi and today I'm going to discuss that basically how a function that is matrix power, how basically this function works. Now this matrix power is one of the functions that is in a number and basically we just use this function in matrix itself, right? So now today we are going to see that basically how this matrix power function works and basically what are the rules and like what are the ways basically how which like you can use while using this matrix power. Okay, so for that, just let me start writing some of the things, and here I would just write as matrix. Okay, matrix power. So it's matrix power, right? Now what next I have? Now at next what I have. Firstly, I would just tell you that basically this matrix power function, what does it work for? So this matrix power function basically works only for the square matrices. Other than the square matrices, you cannot like apply this matrix power function in any other matrix, in any other like matrix. Okay. So here I will just mention that thing. I will just delete that and I will write that works on only, and here I would just I would let me close that. I would just write works on only square matrix. Now what are the square matrices? Are that 2 cross 2 matrices, and these all are the 2 cross 2, 3 cross 3, 4 cross 4. So all these basically consist of these square matrices. Now in a square we don't have that square matrix is only of 2 cross 2. No, we don't. We cannot see that square matrix is only of 2 cross 2. It can be of 3 cross 3. It can be of 4 cross 4. It can be of 5 cross 5. The thing is that number of rows and number of columns should be equal to each other. Then the particular matrix is called as a square matrix. Fine. So this is the idea behind using this matrix power, and basically this is the way how you can just use a square matrix. Now what next we have? Next I'm just quickly let you know about the syntax, that basically what is the syntax that we use. So I would just write here as syntax, and now what I would just write here the syntax. Now the syntax which we use is basically numpy dot linalg. Now like basically the previous video is I just told that what is this linalg. So this basically belongs to the linear algebra, right? This lin for linear and this alg for algebra. So this was about the linear algebra, and we were just seeing that basically what are the techniques which we like we can use in this algebra. So there we were just having 4. So in the previous video I've just discussed about the first. Now today we are just going to discuss about the second, that is power of a matrix, right? Now I will just write numpy dot linalg, that is linear algebra. I would write dot, and here I would just use that function, and that is matrix power. Okay, so matrix power, and then I will just put the bracket. So this is the whole syntax for using this matrix power function. Fine. This was the thing. Now what else I have? Let's say I just have a matrix that is A. Fine. So now what I would just use? I would just use this numpy dot linear algebra linalg. I would just write dot matrix underscore power, and inside the bracket, now inside this brackets basically what we write. Now what is this A? This A stands for the name of like in the variable in which I have just stored my array. So that is A. Now what about this N? Now what is this N basically? Now this N stands that how much power you want. Let's say, okay, let me just quickly give you an example for that, and then we'll basically proceed with the practical for this. And before that is, let me tell you that one thing, that in if like the value for n you have entered 0, then what you are going to always get, you are always going to get an identity matrix in the output. Identity matrix. Now what is this identity matrix? That 1 0 0 1. So this is called an identity matrix. You have like surely studied in your matrix whenever you have studied matrix in your like classes or in your graduation somewhat. Okay, this is about the matrix. Now what next we have? Next we have 2 more conditions, if n is greater than and even if n is less than. So now what I'm just going to write here, that if n is greater than 0, then what's the case? Then repeated, then what will happen? Repeated addition, repeated, I will just okay, repeated squaring and multiplication. Now what I just mean from these things, I'm just going to explain you things in a while, but before that just make the proper notes with me only, right? I'm not writing all these things for me. Okay, I'm just writing these things for you so that you can just have a proper note for each and everything whatever you are learning here. Fine. And the last condition which I have, that if the value for n is less than 0, then what's the case? Then inverse, then Okay, let me just leave a little bit of space. Inverse then raise to the n. Okay. Now what does this n basically means? Now if I have just written this n here, this means that you need to give this much power. As we are just dealing with the power function, right? So let me just go above. And what was our like today's topic? Today's topic was matrix power. Now if I just want to like deal with this matrix power function, what will I do? I would just give some power to my matrix, right? I would just give some value that, okay, I just want this much power of my matrix, or I just want to calculate this much power of my matrix. So basically we will do that thing, right? So that in the case itself, I just taken this n. So this basically this n belongs to that power only. Okay, you want two, you want square, you want cube, or you want to like keep the power as 0, you want to keep the power as 5. So all that things basically this n n variable contains. So this was all about the conditions which we have, and even that basically what's the syntax for writing this power matrix power function. Now quickly let's move towards the Python. Let me just quickly open that thing. And here what we are going to do here, just I'm going to write some code and we're just going to execute some programs. Fine. So firstly, what I would do, I would just import my library, and that is Numpy. So as you all know that basically before using the Numpy library, what we do, we just import that. I would just write I would just write 1p import Numpy as np. Right, so this is the way for importing a library into your PyCharm file which you have just made. And yeah, so before importing this NumPy, if you haven't downloaded NumPy in your in your device, whatever you are using, so if you're seeing this video for the very first time, then what you need to do is that quickly go and see the very first video for this, and then you can just come back to here. As whenever we use NumPy or Pandas, any special library in any of the IDEs, then we just need to install that library in our device. In that ID, we just need to install it. So for the installation process, I have already discussed all of these things in my previous videos. Just go and have a look there. Fine. So import NumPy as np. Now what I'm just going to do here is that I'm going to declare a library, matrix. I would just write np dot array, and let's say here what I'm going to give a 2 cross 2 matrix. Let's say I just give 3 comma 4. I will just put comma, and here I will just write 1 comma 2. Okay, 1 comma 2. So let's say this is one of the matrices which I have just taken right now, that this is 2 cross 2 matrix, and let me just quickly print that for you. Let me show you that thing. So I will just run my program, and yeah, here we go. So okay, just let me it will take a little bit time. Fine. Okay, so here I just got my matrix. It is 3 4 1 2. So this is basically a form of 2 cross 2 matrix, 2 rows and 2 columns, and even it is a square matrix, right? So yeah, we can just perform the matrix power function in this. Now what I am going to do here is that I'm just going to write np dot what I would just write np dot linalg. So again what I'm going to do is that I would just comment this print statement. I would just write b is equal to np dot linear alg. Okay, np dot linalg, and what I'm just going to do here is that I will just put again a dot. Now I'm going to use my matrix power. So I just wrote matrix underscore power, and here let's see the variable in which I have stored my matrix, that is a, right? So I have just taken that a this side. Now what I would do is I would put a comma. Let's say I just wrote 2 here. So this means that I need the matrix power to the power matrix to the power 2. Okay. Okay, just let me print that thing also. I will just write print and then b. Now just let me run the program for one more time, and yeah, here we go. So basically now see here what I got as the output, that is 13 25 8. Yeah, is this a square of 3 4 1 2? No, it's not the thing. Okay, so here I have one more new thing for you, and that is basically when I just see the term that it is power to this thing. Let's see the okay, this pen is too much thicker, so let me just take a little bit fine pen so that I can just write it properly. Fine. So whenever I just say that I have taken a matrix and the power for that matrix is this 2. Let's say I have just taken a matrix, I've written a comma 2. My matrix is for here, I'm just taking an example, that is 3 comma 4 and 1 comma 2. This was the same matrix which I have taken at that side, right? Now when I just say that power for this matrix is 2, so basically that does not mean that I'm going to square each and every term of the matrix and I'm going to get the output after squaring each and every term of the matrix. No, that's not the case. It is totally not the case. What is happening here basically, the whenever we say that we need to square the matrix like A square, so what happens is that we multiply A into A. If we want to just take the cube, what we do basically we write A cube and then we multiply the matrix that is A 3 times. So it does not mean that you need to like take a particular element from a matrix, whatever the positions they are there, and you need to square them. No, this is not the case, not at all. So what you need to do is that if I'm just writing A square, so that means that you need to just square your matrix. Square your matrix in the sense you need to multiply your matrix 2 times. Okay, so basically whenever we write 2 to the square, okay, when I write with 2 square, so what we do basically multiply 2 cross 2, right? And then we just got the output as 4, and that is the like 2 to the power 2, right? So this is the whole case which is just happening here, that if I'm just writing A square, so that means I need to do A into A, not A squared, fine? So that is only happening this side, and after like doing that things, I'm just getting the required output. Now I'm just not going to multiply and verify, you can just do that thing on your own. So basically this is the like output which I am getting here, fine. I will, if I just change this 2 to 3, fine. If I just change it to 3, now I will just get a different output, because now here what I am doing, I am multiplying my matrix that is 3 4 1 2, that's my square matrix 3 times, right? Because I have written here as 3, so it does not mean that I need to do the cube for each and element. No, what I would do, I would just multiply my matrix 3 times, and there I would be getting the matrix power, fine. And so there I will be just getting the required output, like whatever the output which I have wanted, fine. So this is done. Now what else, I would just like write here as 0, and now when I will just run my program, see what did I got here. I just told that whenever we are just going to write our n as 0, so here I just wrote my n as 0, so right, let me go to OneNote and open that thing only where I have explained. So yeah, so here what I have written, n is equal to 0 and identity matrix. So whenever I just said that whenever we write n, like whenever we get the value for n as 0, then always we are going to get the identity matrix. And so here we got the identity matrix that is 1 0 0 and 1, fine. Even we can just give any negative number, let's say I just write -2, then what I'm gonna get, okay, so yeah, so here I'm just getting some like any output here that is like -2. So basically what did I told for you, for the negative values, that it will inverse and then raise to the power n. Firstly what it will do, it will like inverse my matrix which I have, and then it will just give it a particular power, whatever power like we have mentioned. So how to check the, like how to get the matrix inverse of matrix? So for that also I have already told you this thing in my previous video, so you can just go and have a look at that site, okay? So here what today I discussed about that how you can just like give a parameter for the power of matrix, and if you just want to calculate something about that matrix, so how you can just do that thing, right? So this is all for today, and we have just discussed about the matrix power function. Now in the next also we are just left with 2 more functions for this linear algebra which I just told. So we will be discussing that in the further videos. So this is all for this video. Till then, thank you and bye bye.